Now coming to the property of the D block, that is the alloy formation. You'll be surprised to know that most of the alloys which we see in our general routine life, that is the brass, bronze, gunmetal and many more. Actually, you know that these alloys are actually made up of transition elements. As you know that brass is formed of copper and zinc, copper and tin. Likewise, there are many actually, most of the transition elements, they actually lead to the formation of the alloy. You know that what is alloy actually, as you all know, but still I want you to discuss it again with me, that alloy is an homogeneous mixture of two or more metals. Alloy is an homogeneous mixture of two or more metals. So that means what we do actually, we take selected metals of desired properties, we heat them, and what happens, they melt, and when they melt together they just combine to form a single substance. That is what is the alloy, and now it is going to possess the properties of both the metals, both the desired properties. So here what I am talking about is that during the alloy formation, the elements which are actually used, the metals which are actually used are transition elements. And you know that why the alloys are actually formed of transition elements? This is the reason behind it is that they are of comparable sizes. Their sizes are almost same. So what happened, see what I have told you, that whenever the alloy is formed, the place of one atom is to be substituted by the another atom. So this can happen easily actually because they are of comparable size. Suppose we heat them, the lattice just gets open. So what happened when they start, you can say when we cool them after that, after heating them they melt, and then when they are cooling down, so what happened, the element of any transition element can actually take place of the another. So they can easily substitute their places, and this is what we need in the formation of alloy. That means the crystal lattice, the definite arrangement should get disturbed actually, and it should be substituted by another element. This what can happen in case of the alloy formation. So that is the reason they are generally found in the composition of many alloys. Likewise, they have the catalytic properties also. As you all know that catalyst is a substance which can affect the rate of reaction without undergoing any change in itself, right? Catalyst is a substance which can affect the rate of reaction without undergoing any change in itself. So as we have seen about the catalytic properties or about catalyst, there are many transition elements. They are mostly actually transition elements which are playing a role as a catalyst. Like we have nickel, we have vanadium pentoxide, we have palladium, we have platinum. These all are actually the transition elements. And you know that what is the reason that they can act as a catalyst? See, what the catalyst is going to do, it is going to affect the rate of reaction. It can increase the rate of reaction, and likewise it can decrease the rate of reaction. So that means it has an effect on the rate of the reaction. And to affect the rate of the reaction, like suppose I want my catalyst to increase the rate of reaction. So how it is going to increase. Either it will help in the adsorption process, that means in the intermediate formation complex that we have already discussed when we were discussing the catalysis. And second, what it can do is it can just lower the energy barrier so that more and more reactant can cross that energy barrier and they can cause effective collisions. So catalyst can, the transition element can actually fulfill both of the function. One is that it has vacant d orbital. It has actually a vacant d orbital, and due to it, it can actually carry out the adsorption which is required, and moreover, like when the adsorption is occurs, so that means it will lead to a intermediate complex formation also. So this can actually happen easily in this case for the transition elements, and moreover, what it can do is it can lower the energy barrier also. It can lower the energy barrier also, which is required so that more and more reactant can cross that energy barrier to cause effective collisions, and this is what we need, because if there will be collision, effective collision, then only the old bonds will get broken and the new bonds will be formed. This is what we need in it actually. So we can say that transition elements they act as catalysts because they can perform they can actually affect the rate of reaction by performing two important tasks, that it can help in the intermediate formation, it can provide the surface area for the intermediate formation or a reaction to occur, and second, it can lower the energy barrier. So this is what is the catalytic property. Now moreover, we have few more properties, like we are discussing about the magnetic properties. So if we talk about magnetic properties, we have depending upon magnetic behavior, we have many kind of behavior what we see in daily routine, that is the paramagnetism, diamagnetism, ferromagnetism, we have such kind. So here what I have taken is I have taken two important magnetic properties, that is paramagnetic and diamagnetic. So what is the difference between two? Paramagnetic substance is that which gets attracted to the magnetic field, and diamagnetic is that which is repelled actually by the magnetic field, or you can say a substance will act as paramagnetic if it has an attraction for the magnetic field, and if it has a repulsion it is called as diamagnetic. Now what suggests that the substance is going to be paramagnetic, or what suggests that the substance is going to be diamagnetic? It is only the electrons, it is only the electrons. For paramagnetic character, the substance should have unpaired electron, and for diamagnetic behavior it is shown by paired electrons, right. So if we observe, like when we are moving in transition series, we know that like for example we are moving in first transition series, there is filling of this thing the 3d and 4s orbitals. So what happened, you start with scandium, it is 3d1, then 3d2, 3, 4, 5, likewise successively the d orbital is being filled. So we say that when it starts filling, actually the unpaired electrons are increasing. And as we know, when the unpaired electrons are increasing, that means paramagnetic behavior is increasing. But after D5, what you observe? See, this is my D. So the time I reach this point, then afterwards if I'll add more electron to the D, obviously the pairing is going to take place. So that means unpaired electron is going to decrease, and when there is decrease in unpaired electrons, we know that there is decrease in the paramagnetic character, or you can say there is an increase in diamagnetic character that time. So we will say that as we move in a period, as the unpaired electrons are increasing, so paramagnetic character is also increasing. But after D5 we observe the pairing, and the pairing leads to decrease in the paramagnetic character and increase in the diamagnetic character. So this is what is the magnetic behavior. And you know that if we want to see, actually we can calculate about the magnetic behavior by looking at the magnetic moment, and we can calculate it by this formula, that is mu is equal to n into n plus 2 square root, or you can say the Bohr magneton. So as there is more value of magnetic moment, so more is the paramagnetic character, less value of magnetic moment, less is the paramagnetic character. So this is what you can account for the magnetic character for the d orbitals. Likewise, we have the chemical reactivity also, one of the property. So we have seen that we have D block elements here, we have S here and P this side, right. So if we compare our D block elements with the S1, they are of smaller size, right. And if we compare with the P, they are of more intermediate size. So what we actually observe, if we talk about their reactivity, so they are generally less reactive. They are generally less reactive as compared to the S and P both. The reason being, they have high ionization energy, they have high sublimation energy, and they have low heat of hydration. For the substance to be reactive, it should have the low ionization energy, so that we can easily extract the electron. And likewise, it should have the low sublimation energy, because any electron enters into the orbit or leaves the orbit, it happens only when the atom is in gaseous state. So so for doing any of the task, we need to convert the solid metal form into the gaseous state, and there we need energy that is equal to called as sublimation energy. So it should be low actually, but in case of transition elements, it is high, right. And likewise, low heat of hydration, that means when it is dissolved in water, because most of the reaction occur in the aqueous medium. So the energy which is liberated is actually very low, and as we know, more is the energy liberated, more stable is going to be the compound. So this doesn't happen in case of this D block elements. So we can account for their less reactivity, that they are actually less chemically reactive, but still you know that we found them in a reactive state with some of the elements, and they are generally sulfur, oxygen and halogens. Sulfur, oxygen and halogens. They mostly found in combination with these elements, that is sulfur, oxygen and halogen. And you know that when they combine, as I've already we have discussed, that they can show different kind of oxidation states actually. So when they combine, they have a compound with low oxidation state also, they have a compound with high oxidation state also. So when they have a compound with low oxidation state, that means it possesses many unpaired electrons, and when many unpaired electrons are present, that account for its basic character, because it has now it has the electrons actually which it can donate it to another. But when the compound is present in higher oxidation state, it means there is no unpaired electron left. All of them is just used in the bonding. So that means they are now going to act as acids, Lewis acids, because they need electrons now. Right. So this is how you can account for the compound with the low oxidation state, that it is basic or acidic, or how you can account for their less reactivity, and this is what is the chemical reactivity, right. I think you got it. And whenever you are talking about chemical reactivity, just make it clear that what are the reasons actually which determines its any reactivity. And moreover, see, when we are talking about alloy, when we are talking about catalyst, we are talking about magnetic behavior, we are talking about reactivity, or we are talking about any other property, you should be clear in your mind that what factors you have to focus for this element, because actually the factors are same for even it is S block, P block or D block, the factor is just the same. Right. As you have some of your friend, and you have to make out that whether your friend is a good friend or a bad friend, there are certain set of qualities that a person should fulfill, right. So that qualities remain same whether you look for a boy, whether you look for a girl, whether you look for any human being. So those properties actually decides that whether the person is a good or a bad. Likewise, when you talk about the alloys or the catalyst or any of the properties, they are the basic factors actually on which those properties depends, or which determine that what is the nature of this property for this given element. So just focus on that basic thing that determines the properties, and as you will be clear in your thoughts about that the factors on which the properties depend, you will be easily going to make out that what this element is going to behave, because all the properties are almost interrelated, right. So this is what is the alloy, catalyst and magnetic behavior and the chemical reactivity. So now we are going to look for many more properties. Just look at the board.